Hey, congratulations on passing the Chapter 4 test. Really excited. Welcome to Chapter 5, where we're working on division and proportions in algebra. We can see the contents on this. This is a fairly lengthy chapter, but a lot of good information, a lot of chance to practice algebra in a lot of different ways. Read through the chapter opener. There's some nice stuff in here about algebraic fractions, how they work, the whole invert and multiply idea. There's also this idea of splitting things up to view it as a fraction as being equal parts of some whole. Rates are defined again, and they are quantities with different units. Ratio have the same kind of units. So we've got a few different discussions here of topics we've seen before, but we're going to be applying some algebra in solving them. Well, let's get on with 5-1, the multiplication of algebraic fractions. What do we mean by algebraic fractions? Well, that is shown right at the beginning. There's some examples of various fractions that could be considered algebraic ones, and you should know what this is. It's under your vocabulary. You should be able to find some way to define that. The multiplication of algebraic fractions, one of the models we show is the area model, where we have a unit length on the side and we're dividing that up and multiplying the fractions together, and then the shaded area would be the area that would include both fractions. In this case, it would be AC over BD. We've got a few examples, and I will go through some similar examples, so do go through these, practice it yourself. I'll have additional ones if you need help. The equal fractions property for all real numbers a, b, and k. If b does not equal 0 and k does not equal 0, then a over b is equal to ak over bk. So this tells us if we multiply the top and bottom, the numerator and denominator of a fraction, by the same value, then the fraction has the same value. It just has a slightly different representation. The equal fraction property shows what it holds for. We've got an example 3. For this activity with the CAS, you should be able to plug this in and crank it through your CAS and get a result. I will, at the end of the examples, give you the answers for these, so look for those in the latter part of the video. Example 4, a couple other problems that we should solve. Again, I'll go through something similar. You want to work through this. Covering the ideas, applying the math, and get ready for the mastery quiz. Okay, we're on 5-1, the extra examples. Here's our first one, which is example 1. Multiply a over 3 times b over 5. So we're just going to basically take our multiplying fractions property and say that this is going to equal a times b all over 3 times 5. And well, I can go ahead and simplify that, and since we don't typically put the multiplication symbol between letters, we simply would write AB over 3 times 5 is 15, and there is your multiplication right there. That's example 1. Example 2, show that each of the following expressions equals 2i over 7. So we've got 3 different expressions. We want to simplify these. So 2 over 7y is, again, using the multiplying fractions property, 2 times y over 7. And we don't put that multiplication between a number and the coefficient of a variable. We just write 2y, which means 2 times y, and 2y over 7. For the second one, again, we got 1/7 times 2 times y. The multiplying fractions property tells us that that's 2y over 7. and we've shown that one. And here finally 2 times y over 7 is 2y over 7, and we are done. They are all three are equal to the same 2y over 7. Here we are in example 3, which asks us to simplify a fraction. We have an algebraic fraction, so we've got numeric terms as well as variables. We want to look at what that'll look like. Well, the variables are easy. The y over y, that reduces to being just a 1. So I have 108 x over 9, because 1 times anything is just that thing. And now we've got to see whether 9 will go into 108. Now you could grab your magic calculator. You could also go ahead and just try to calculate it. I know that 10 times 9 is 90, and that 11 times 9 is 99, and 9 more than that would be 108. So 9 goes into 108 12 times. So 9 goes into 9 one time. 9 goes into 108 12 times. And that tells us that we then have 12x is our answer to the simplification of this fraction. Okay? Questions? Ask. Okay, one more, and then we'll be wrapping up 5-1, let you get on with your work. And here, for example 4, we're going to multiply to get a rather complex product and then simplify the result. Or we could try to simplify along the way rather than simply multiplying everything together. And because of our multiplying fractions property, we can see, I'll show you how that could be done. We're assuming that x doesn't equal 0, that y does not equal 0, and we'll go ahead and do our multiplication. That would be 6x squared over 35y times 7y over 3x cubed. Now our first step in simplifying this is I could go through this and find where I have common factors, but let me rewrite it in a way where I can put them together. Since I can use the multiplying fractions property, I can put this all over one fraction bar. 6x squared times 7y, and that's over 35y times 3x cubed. Now we remember that multiplication is commutative, so I can move things around in the equation. And so in doing that, I can organize it in a way that I could see that I can easily cancel things out, or I could just do it if you see it right now. So 6x squared, that's going to go over my 3x cubed, times 7y, which will be over my times 35y. So I just swapped the location of the terms in the denominator. Well, x, I've got two x's up here, that's x times x. Those are going to cancel out, leaving me with 1x here and 0 x's up there. And 0x is just 1. X to the 0th power is equal to 1. 3 goes into 3 one time. 3 goes into 6 two times. So I've divided both sides by 3, or divided top and bottom by 3. Now I'm going to go ahead and look at doing this through 7. 7 goes into 7 one time. 7 goes into 35 5 times. So now I can rewrite this. I'm going to come over here with it to the left side, and I have 2 times 1 times 1y, because that x to the 0th power is just 1, and that's all over 1 times x times 5y. And now the ones are just identities, so I can not worry about those. I'm going to end up with my final equation is, let's see, 2y over 5xy. And it looks like it's not my final equation. I've still got a y I could cancel out here, because y over y is just 1. So that becomes a 1, that becomes a 1, and I'm left with now 2 over 5x. This is my simplification of the product. So that's some work for 5-1. You have the covering the reading and applying the math, followed by the mastery quiz. Good luck with that, and I'll see you when you come for the quiz.